Hello there. So in this video, we're just going to talk about general strategies for proving trig identities because there are several, and it just is super helpful to have some strategies to try. So just some general things. I always start with the side that is more complicated. So if it says it equals like blah 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 equals sine theta, then you start with the I like to think long story short. You know how I tell stories that are way too long and you just wish I would be like, here it is? Start with the long side, get to the short. Now, what if both sides, you're not sure which one is better? Well, you just start at one, and if it doesn't work, then you stop, abandon ship, and try the other one. That's how learning works. So if you start with the side that's more complicated, you end with the side that is less complicated. Now, you have to just, you can mentally meet in the middle. However, you have to, work from, if you pick the left side, you have to work all the way down the left side until you get to the right side. Or if you start with the right side, you have to work all the way down the right side until you get to the left. Now, usually what I think of is right at the beginning, I'm like, I think this could go here. Let's see, move all the way down until you get to the place where you're like, now we can meet it, and then you just finish that step off on the side. Each intermediate step must be easily seen as equivalent to the previous step, so you can't just skip steps here. You have to show all of the steps. Why is this valuable? Because in your life, whether you do trig or calc or anything like that for an actual living, like a thought process and being able to explain steps clearly, how did I get from here to here to here, that's a valuable life skill. So we're practicing that through mathematics, and it's a valuable life skill with the math and without the math. Okay, now specific problems. What should I do? Well, I always look at it first and I'm like, okay, can I convert this to sine and cosine? Oftentimes you can. So if you see secants and cotangents and tangents, go sine and cosine. Now if it's tangent squareds, generally you'll go to sine squared over cosine squared. Now tangent squared also equals, I don't know, something else with a secant squared and a 1. But we don't generally go there. Generally we think sine and cosine first. Like in softball, generally we think hit away. That would be the sine and cosine. Now, sometimes you bunt. That would be going to a different thing, like 1 over cotangent. Okay, so generally convert to sine and cosine. That's the old reliable. If nothing else seems to work, try that. Okay, 2. Oh, I actually want to write a 1.5. I would say 1.5. 1.5. 1.5. Look for squared. Okay, squareds. That's not really aka Pythagorean identities. Okay, that's terrible. Okay, Pythagorean identities. If you see something squared, it's oh! Especially if you see a sine squared. See if you can find a cosine squared, because they always equal 1 when they're adding. Okay. Then, after that, combine terms by getting a common denominator. That happens a ton. If you're ooh, fraction, common denominator. This works well if you're going from 2 terms to 1. Now, what if you have on the top of a fraction a plus or a minus? Well, then you can actually split it apart into, 1 term to 2 or 3 terms. Right, now this is later in the notes, but I'm just going to have this video being things to try if you don't know what to do. Multiply by the conjugate. Okay, so what even is a conjugate? So say, for example, I had conjugate. If I had sine theta over 1 minus cosine theta. This happens often. Then, I could multiply by the conjugate on the bottom. What is the conjugate of this? The conjugate is it makes a difference of squares. So it would be 1 plus cosine theta. Okay, and then you do 1 plus cosine theta up here because you have to. Okay, well, on the bottom, if you think way back to algebra, 1 plus c, 1 minus c. So you get 1 minus c squared. And then the middle plus 1c minus 1c, like the middle simplifies out. So you get 1 plus cosine squared. No, 1 plus, 1 minus. I'm just going to do 1 minus cosine squared theta. Now, and then on the top, like the top, I'm not super concerned about the top right now, but the bottom, 1 minus cosine squared turns into sine squared. So then you could simplify some things out. Okay. Oh, you could also factor the expression. Oh, I love this. There's so many types of factoring. We've done that a lot lately, like greatest common factor, normal factoring, difference of squares, sum or difference of cubes. Oh my gosh, we won't do sum or difference of cubes here, but you could. And last but not least, be creative. Like just like blow stuff up and try something. Like that's my philosophy in life sometimes. It's like, I don't know, so woohoo, I'll try this. Can't be too creative. You're bound by the laws of algebra, but if you're not sure, just try something. And if you're wrong, start over. Like, again, life skill. There's things I do wrong all the time and I have to start over. It's good practice for life. And those are some good methods to try.